I've been wanting to do this for a long time. I've been trying to figure out what kind of book I could use. So this Modern Automotive Technology books by James E. Duffy is available online. I'm taking. Oh, congratulations, man! That's incredible that you're almost on that Mercedes-Benz program. Best of luck. Um, this book is available online, PDF, download for free. That's why I'm using it. It's an incredibly good book. Starting out pretty simple, pretty straightforward. So let's get into it. So learning objectives for this particular presentation, we're going to understand automotive systems and like some terminology. We're not going to go too crazy into it, but we're going to understand some systems, some terminology. We're going to recognize some career pathways, in the industry, and some ASC certification areas, what ASCs are they important, whatever. Um, Talk about safety. Safety is also always very important, and kind of appreciate the technician's role in the service industry. There's a lot of negativity that goes into or there's a lot of negativity you'll find online about being a mechanic, about being a technician, the differences between a technician and a mechanic, and all these different cultural things and all that garbage. That all of that is just a bunch of nonsense. I think what really matters is appreciating that like we have a very important job, whether you're changing oil or rebuilding transmissions. Everything is very important. So some basic terminology here. An engine or an engine system. We don't have we don't have very simple cars anymore. We have I like to use the term an engine system because we have gasoline engines, diesel engines, we have turbocharged engines, we have supercharged engines, we have twin charge engines, we have hybrid engines, right? We have plug-in hybrid engines, we have engine systems, and then we have like EVs, which those are motors, not engines, et cetera, et cetera. So there's engine systems of vehicles. There's fuel and exhaust, right? Fuel allows combustion, exhaust gets rid of the combustion. Um, there's electrical, right? So everything nowadays works on electrical inputs and outputs. We're going to get into that a little bit later in the next lecture. Drivetrain. A drivetrain, like you'll hear me say drivetrain a lot. And we're going to go into different types of drivetrains later in this lecture. And all a drivetrain it's what transfers the engine power to the wheels, right? So there's different ways of transferring engine power, horsepower, torque, whatever you want to call it, to the wheels to make the car move. We're going to talk a little bit about suspension, steering, brakes. Okay, so suspension, steering, and brakes, that's control and safety. You have all the power. You have everything that you want. Um, but how do you control it? How do you stop? How do you go? That's suspension, steering, and brakes. And then, of course, cooling and lubrication. You're going to need oil to lubricate your engine. You're going to need cooling to keep the temperatures good so that you can combust efficiently and so that you don't, break the engine. And then you have your accessories for comfort and convenience. Accessories meaning air conditioning, power steering. Um, you have alternators as an accessory. It's less of a comfort and convenience, more of a necessity. Right, Luke, thank you for sharing the live. 4.8 thousand likes already. That's amazing, guys. Thank you so much. And here's a really great zoom into this for you. Pretty simple, and this diagram is straight out of the book. Um, this is how a car works, right? In a very um, straightforward way. You have your fuel that's in your fuel tank. Your fuel tank goes through a fuel pump, a fuel filter, and then fuel injectors into your engine. At the same time, air is going into your engine, and it is combusting. Okay, you have a spark plug. If it's a gasoline engine, that's your ignition system, or it just uses compression where if you had a diesel engine, and then all of those gases come out in your exhaust, and while the engine spins, it spins a drive shaft if it's like rear-wheel drive or all-wheel drive, and then it spins your axles and it moves your wheels forward. You have a charging system that keeps your battery charged, and then you have a fan and a cooling system and a radiator to keep temperatures under control. And we'll go into a more detail later. So far, any questions? You got your A5 test tomorrow. You best of luck, Devin. Any questions about this so far? We're good. Yo, what's going on? Alex, I will answer that question once I get to the ASC portion of the lecture. The short answer is yes, but I'm going to get into more detail later. Okay, cool. So let's talk about different types of vehicle builds. We have two main types of vehicle builds. The first one's called a frame on body. These are your pickup trucks, your small pickup trucks, small pickup trucks, your larger SUVs. We're talking like GMC Yukon, Chevy Tahoes. We're talking Ford Expeditions, Ford Broncos. We're talking Toyota Tacomas, Toyota 4Runners, right? Tacomas, Tundras, a body-on-frame vehicle. What that means, you have a frame that supports mechanical assemblies and a body that provides structure and aerodynamics, and a passenger compartment. It's where you sit. Proper alignment ensures ride quality and safety. So like proper alignment of both the body and the chassis is important. And here's a larger picture of what we have going on. So this steel structure underneath, that's called the frame. All right. Oh, I actually just noticed you guys don't see my mouse. That's interesting. Let me see if I can change that over here. Give me one moment. Oh, it says capture cursor. I did capture the cursor. But you guys, oh, here we go. Hey, there's my mouse. So, oh, Cole, what's up, dude? I'm not gonna say your full name because we're on the internet, but what's up, man? Hope you're doing well, dude. So, this is the frame. Oh, I guess here we go. This is the frame, and you can see here your suspension is attached to the frame, your brakes, all that stuff is attached to the frame. What's not pictured is your engine, transmission, your drive line, like we were talking about in the previous slide. That is not uh, uh, pictured here, but that's where all of that fits, and then you have the actual body of the vehicle put on there. Now there are many advantages of a body on frame setup. One, it's very simple, pretty repairable, and it's heavy duty. There's a lot of structure involved, right? Like you could build some really heavy stuff and do some heavy things on these body on frame vehicles. The negative side though is safety. They're not the safest vehicles. I was like kind of like asking myself, like, do I want to do like a car crash, IS one of those car crash safety videos, but I'm afraid that would kind of get me kicked off of the live. Diesel's first. Thank you very much for the follow. So um, I'm not going to do that, but you can go ahead and Google like a Ford F-150 crash test versus a unibody crash test, and I'll show you what a unibody is. So a unibody is this other form of vehicles that we have, and this is just about every car, right? That's out there, and even some small trucks like the Ford Maverick. So let's zoom in here, and I'll give you guys the whole point of a unibody is essentially it's a safety structure that you bolt an engine, transmission, and drivetrain into. It's like having a roll cage that's already built in. You got your bumper support, and you have something called crumple zones in these unibodies. And the crumple zones is what makes cars kind of squish together. And although that doesn't, basically one bad accident and the car is done, but what that does is it makes these cars infinitely safer. You have we saw that on the body on frame vehicle that this was attached to the frame, these suspension supports, and these are actually built into the body in the unibody platform. You have a roof frame, and you could just see all of the structural rigidity, and that's the magic of these unibodies. And then you have your drivetrain, you have your suspension, your brakes, you have your engine and transmission, you have your exhaust system, you have a shift lever here, your fuel system back here, and then all your rear suspension, rear components. And all they do is just like that, it just bolts right into itself. So you have a safety structure that a powertrain bolts into. And what that does is that it allows us and it allows engineers to build certain types of vehicles, so many different types of vehicles. You can only be in so many. You can only build so many types of vehicles with a body on frame, but you can kind of do whatever you want. with these unibody platforms. So you have your sedans, you have your convertibles, we have our hatchbacks, station wagons, the sport utility vehicles. We have minivans. These are like the main types of vehicles that we have available on the market. And I'll say what, have you ever been in a crash? Yeah, unfortunately, too many. So let's go to the chat here. So for this sedan, let's see who can give me an example of a sedan in the comments. Go ahead. You could either tell me what car this is, or you can give me an example of a sedan in the comments. Um, let's see if Corolla, perfect, Toyota Corolla. Okay, this is a convertible. Let's get it. Let's get one of a Ford Fusion, Audi A6, perfect. Convertible. Let's get some examples of convertibles. What kind of car is this, for example? A Porsche 911, perfect. Hatchbacks. What kind of hatchbacks do we have? And I'm gonna ask a really interesting question here too after the hatchbacks. That's a Ford Fiesta, Focus RS, the hatchback. Now here's a station wagon. What's the difference between a station wagon and a hatchback? Honda Civics. Some of the Honda Civics are hatchbacks. Chevy Bel Air body on frame sedan. Yes, it is. A Ford C-Max is also a hatchback. Um, one door. Mazda Speed 3 is a hatchback, but what's a station wagon? Let's see if someone. I just want to see what anyone in the comments says, and then I'm gonna go ahead and I'll just answer it. So the main difference in a hatchback and a station wagon is station wagons, one door is the difference. I don't understand what you mean by one door is the difference. Four-door car, large cargo space, yeah. So a station wagon is basically a very long car with a hatchback, and a hatchback is just a small, compact vehicle. We have our minivans. Audi Q7 is also a Subaru Crosstrek. Yep, Nissan Stagea. Yep, a man has some taste there. Minivans. Let's throw some minivans out there. Toyota Sienna, probably the best one out there. My favorite minivan statistic is Chrysler currently in America only makes one vehicle, and it's the Chrysler Pacifica, and it's the worst minivan you could buy, and I think that's hilarious. It's sad, but hilarious. All wagons are hatchbacks, but not all hatchbacks are wagons. That's a very good Florida man. Typically, Florida mans don't make some good points. It's a very good point there, Mr. Florida man. And a sport utility vehicle. So let's get a sport utility vehicle. What do we have there? Give me some examples of a sport utility vehicle. Yeah, Chrysler doesn't make any more cars right now. Ford Bronco Sport, a Bronco Sport. Yep, a Dodge Nitro. That was a very good car back in the day. This is a Jeep Renegade. Jeep Renegades are terrible. A 4Runner is an SUV. It's not a well, okay, yeah. I guess I'm thinking of a crossover, but yeah, 4Runner. Yes, it's an SUV. Sorry, I'm sitting here saying sport utility vehicle. Yeah, my bad. Cause I'm thinking of crossover, but yeah, two-door Wrangler. You got it. Absolutely, great job, guys. We have a great class here. So let's get into it. So like I said earlier, one of the advantages of the Univati platform is that you get to really make many different drivetrains within a relatively simple platform. Renegade is better than the Kia Soul. Man, I almost disagree with you there. I almost disagree. I think they're both equally terrible. So the first type of drivetrain, and this is like the major drivetrain. Everybody has one of these. It's the most made drivetrain. This is a front engine, front wheel drive vehicle. Okay. Your engine is in the front, the transmission is in the front, and the front wheels are driven. It's a front engine, front wheel drive. Pretty straightforward. Next, we have a front engine rear wheel drive. So the engine's in the front. This is a manual transmission. You have your clutch, and then you have a drive axle. You have your rear diff, and you have everything else. So the engine's in the front, and the rear wheels are driven. Who can give me an example of a front engine rear wheel drive car? Let's see it in the comments. Front engine rear wheel drive car. What do we got? An F-250 is a front engine rear drive. But that's a truck. Ford Mustang, absolutely front engine. Hellcat S2000, beautiful. Lexus IS300, G37 Infinity. Not any pickup truck, my man, because a lot of pickup trucks are four-wheel drive. Chrysler 200 is a front wheel drive vehicle. Toyota Supra rear drive vehicles. C6 Corvette. You guys, this is perfect. Perfect. 812 Superfast. Amazing. S Class. Amazing. Amazing, guys. Perfect. Wow. 12,000 likes. Incredible. Thank you, everybody. This is awesome. I'm happy that you guys are enjoying this. So the next one is a mid-engine rear-wheel drive. So the engine is actually in front of the rear axles. It's in the middle of the car. You have a transaxle that drives the rear wheels. So who can give me an example in the comments of a mid-engine rear-wheel drive car? McLaren 720, that's mid-engine. MR2 4Runner, absolutely. The MR2, that's mid-engine rear-wheel drive. Audi R8, Porsche 911 is not mid-engine; it is rear engine, and that's a little bit different. And they're the only that's the only rear engine vehicle on the market. Lotus Emira mid-engine with a Toyota engine. Ferrari F8. A Tesla is not a mid-engine. Tesla is um, it's an EV platform. They're a little different. NSX, absolutely. Honda Beat. Yep, Honda Civic Sport gave me the info. The NSX, yes, perfect. Volkswagen Beetle. The old Volkswagen Beetle were actually rear engine, not mid-engine. Um, so the Volkswagen Beetle and the Porsche 911, I think, were the only rear engine mass-produced vehicles ever made. I could be wrong about that. The next one is all-wheel drive. Okay, so all-wheel drive, you have an engine in the front, and then you have a transmission that has both axles in the front and an output shaft that transfers power to the rear differential, and all four wheels move at the same time. Perfect examples right here: a WRX, a Trackhawk, a 2007 Jeep Commander. Absolutely. A Nissan Stagea. Yeah, I guess some of them come with all-wheel drive. An Audi A4. Absolutely. The Subaru Baja, you better believe it. I think, yeah, Subaru Baja's all-wheel drive. Audi Allroad, all-wheel drive. Absolute. Durango Hellcat, absolutely perfect. Teslas are all-wheel drive, but they will the dual motor or the triple motor ones that they have. It's accomplished in a different way. That's accomplished with electric motors, and much later on in the series, when we get into EVs, we could talk about like those types of powertrains. Uh, Perfect, guys. Beautiful, beautiful. So let's talk about the engine. All right, this is what people like the most, right? Like, oh, we want engine, we want horsepower, we want fuel, you know. Um, so Here it is. So the engine so all the engine does is converts chemical energy to mechanical energy. The chemical energy is in the fuel, okay, and it that combusts and it turns it into mechanical energy that spins things around. All right. It uses the air fuel mixture and the combustion cycle. Requires accurate timing and lubrication, and it's measured in horsepower and torque. And I will say this: measured in horsepower and torque in the United States of America. You got like watts, kilowatts, newton meters of torque, and there's a bunch of different weird power things, But in America, we measure things in horsepower and torque. Thank you, C6 Connor, for the live. Um, how has the Kia Soul held up? I sold the Kia Soul a while ago. Yeah, Newton meters is a lot of Newton meters is in Europe. Uh, the engine, so engines, there's two type of engine cycles. There's the four-stroke cycle and the two-stroke cycle. We're not going to talk about two-stroke cycles. We haven't had a two-stroke engine in a vehicle probably in like 60 years or something like that. So every vehicle on the road, or an overwhelming majority of vehicles on the road, have four-stroke engines. So what does four-stroke mean? Well, there's four steps to this. There's the intake, compression, power, and exhaust. So the intake stroke, compression stroke, power stroke, and the exhaust stroke. You could have this from all the way down from one engine all the way up to we see 12-cylinder engines. It delivers smooth power. Um, Wing ting ting versus blah, basically. Yeah, absolutely. So this is what we're talking about. What's really interesting about the advancements in engine technology is nowadays we have three-cylinder turbo engines that are powering crossovers and small SUVs that are making more horsepower than four-cylinder turbo engines made just like 10 years ago, which is really incredible. So we have this here, and let's zoom in. I want to make a couple of notes, right? I'm going to go a little bit into this diagram, and uh, thanks very much, Copper. I'm glad you're enjoying it. Um, Engines are like in three main components. Okay, you have the cylinder heads, you have the engine block, and then you have the oil pan. Those are like the three main components of your engine. Everyone thinks the horsepower, not everyone, but a lot of guys who get in the field, they think all the horsepower is made in the engine block. They think all the horsepower is made in the crankshaft and the pistons, all the stuff that rotates. That's not true. All the horsepower and torque that's made in the cylinder heads because the cylinder heads are what control airflow, fuel control, ignition, all that stuff. All the turbos and stuff, all the turbo air compression, right? That all goes into the cylinder head. The spark is in the cylinder head. The fuel injectors, they could be in the intake manifold, they could be in the cylinder head, they could be in the block, whatever it is, right? um, but everything is in the cylinder head. Cylinder heads are super complex, super cool, super important. So you have your intake manifold. This is an older style, a waste spark ignition system. But you have your spark plug wires. You have the intake manifold intakes air. That's what it intakes. So air goes inside the intake manifold and then into the combustion chamber. The combustion chamber is where the explosions happen. We're going to get a little bit more detail into what that is. I have some gifs and some examples here just in a second. Mazda does have this I think they call it their Sky Active, which basically uses the both. It's a very high compression gasoline engine that will turn off the spark plug at certain RPMs and it'll diesel itself. So it'll just use compression, and I think it's a beautiful system, and I know those work out really well. This is just I don't know if this is a 3800 or to me it looks like this is actually a Ford 4-liter V6 because it's got this one timing chain here, the water pump here, and I think the other timing chain is going to be in the rear. I think this is actually a Ford 4-liter V6. Oh yeah, look at that. It says Ford right down here. Dang, I'm pretty good. I have this engine in my car, but yeah, this is Ford. This is definitely a Ford 4.0 V6. Ha. So sometimes I impress myself because I'm like, oh, the thermostat housing's right in the front, blah blah blah. So you've got all that going there. Timing chains are very important. We said earlier that timing needs to be precise, and the timing on a gasoline engine is ignition timing, right? So everything needs to be perfect so that when the spark plug um, lights up and produces that electricity, it's going to be right at the compression stroke, and you're going to get all the power that you need. This is the crankshaft. The crankshaft is basically this huge piece of machined steel that all the pistons ride on and things go up and down, and it cranks. It cranks everything. And then that's attached to your transmission, and then you get everything going down to your wheels. So let's talk about the combustion cycle. Let's talk about the four stroke cycle and see what it looks like. So this is what it looks like in real time. This is, call it a carbureted, call it a port injected engine. This is just a simple single cylinder, cross section with overhead cams. Okay, so a lot of vehicles or a lot of like these small engines, one cylinder engines, they'll be flat heads they're called, but all the modern ones there's overhead cams, means overhead camshafts instead of just one camshaft hitting with some push rods and opening the valves. Don't worry too much about that. We're just going to stick here. There is going to be a transmission lesson much later on. We're just doing the introduction. This is the first one. This is number one over here. Um, so you have your fuel going into your intake manifold, and that this is air, right? So the fuel and air go in, the piston goes up. This is called the intake valve, and this is called the exhaust valve. Something really important to note: the intake valve is always larger than the exhaust valve. So you have your spark plug here, and So just the only thing I want to make a note of as I go and do a breakdown of this diagram is this oil level is just too low in this diagram. The reason the oil level is low there is just so that you could see the crankshaft move. But the crankshaft, this oil level should be like kind of like up to here, and the crankshaft is lubricated through, going into the oil. Um, so let's get it. Let's do it picture by picture, frame by frame, stroke by stroke. So let's start with the intake stroke. We have, yeah, you can see my cursor. So we have our fuel and our air going into the intake manifold. Now notice our camshaft right over here pushes down onto the valve and opens up our valve. Notice the exhaust camshaft lobe. So this is called a lobe, right? That pointy part. That's called the camshaft lobe. The camshaft lobe is pushing down on a tappet and opening up the intake valve. The exhaust valve is completely closed, as you can see, because the lobe is not pushing down on the exhaust valve. So we're getting our air and fuel mixture all up in the combustion chamber. This is called the intake stroke. The lobe. This is called the intake stroke. So we got that. Next, we've got the compression stroke. Notice the lobes. The lobes are not pushing down on the valves, which means both valves are closed, and the piston is going all the way up into what we call top dead center. In this frame, it's not completely top dead center, but we're right there. And the reason why it's not completely top dead center is I'll show you in a second. I just wanted to show you guys what the compression stroke is. So we have the intake valve completely shut. We have the exhaust valve completely shut. We have air and fuel, and the piston is moving up real fast. So we are pushing all that air and we're compressing it into a very, very small area. And now we have this guy over here. That's our spark plug. Our spark plug produces electricity at a certain time so that we get combustion. And here we go. This is the beginning of our power stroke. So we have air and fuel. Our air and fuel are in the combustion chamber. Our piston went all the way up, and while it was at top dead center, while it was all the way up, our spark plug uh, uh, sparked and it caused combustion. And now notice the lobes, right? The What are the lobes doing? It looks like the exhaust lobe is getting real close to opening up the exhaust valve. So this is called, so that's compression, and then we have the so this would end up being the, sorry, hold on a second. That's what we'd call the power stroke. So that means all the power, boom, pushes the piston down. So it's called the power stroke. And then we have the exhaust stroke. Sorry, right here. And now we have the exhaust stroke. Notice the lobe. The lobe has now opened the exhaust valve, and now the piston is pushing all of those spent exhaust gases out of your tailpipe. And that's all it is. That is our combustion cycle. That's our four-stroke. That's how basically generally speaking, in the simplest terms possible, that's how every overhead cam four-stroke engine works. Before I continue, do we have any questions? Does anyone want me to explain that again? Is there anything in particular? Um, the crank doesn't sit in the oil, but the crank will can get lubricated through the oil. And we're talking about, I'm sitting here talking about like a single cylinder engine. Um, so how does it get from engine to exhaust on cars with front engine? Because um, it goes through like this exhaust port into a manifold and out the tailpipe. Is the exhaust lobe moving faster? It's not. Okay, I just got here. Yes, please again. Intake, yes, the intake valve is always larger because you're going to want to fit as much air inside as possible. So for an engine that isn't running, most likely air, fuel, or spark. So air, fuel, spark, or compression. Do you have examples of dual and direct injection? I do right now. I do not. When we get into the engine series, right, in the engine lectures, we're gonna get in way more detail. This is the first lecture, so what I'm gonna end up doing here basically is I'm just going into like the basic, way that things work. Um, is it possible for an engine to stop right when one of the lobes on the valves open? Yeah, an engine can stop at any moment for a number and variety of things. And compression could be piston or cylinder walls messed up. Yeah, so compression could mean that the valves themselves. Here, go back to the. Oop, let's go back to this guy here. So this is all compression. On your piston, you have these piston rings, and there's actually called compression rings. Okay, there's two out of three of them are called compression rings. So that seals everything on the piston sides. Or these are called the piston skirts. That seals that all up. Oh, let me get my cursor out here. So that seals it all up. And then your valves create a seal. Your intake valve creates a seal. Your exhaust valve creates a seal, and your spark plug creates a seal. So if any of these are broken, loose, bent, worn out, it could cause a lack of compression. Um, Compression ignition. So this Icarus, compression ignition, or just basically diesel engines, it follows the exact same principle, except it uses diesel fuel instead of gasoline, and there's no spark plug. There are diesel engines with spark plugs, but those are mostly on heavy equipment and like military grade vehicles. When does fuel come into play? I know you just got here, Donnie, but I'll go ahead and I'll state that again. Fuel is right here, right in the beginning. The fuel, the fuel is mixed in with the air and travels into the combustion chamber. This can happen a variety of ways. It could be injected into the port. If it's a carburetor, it'll go right into the intake through the carb, and the air fuel are mixed, from the carburetor goes into it. It could be direct injected into the combustion chamber. It could be both port and direct injected. So there's many different ways the fuel can get in there. However, that's where the fuel starts, right in the beginning with the air. Let's see. Wait, can't see. Where's the fuel? The fuel is right over here. That's in this diagram. The fuel is right here, this little pink box, and the fuel goes right into there. What happens when the exhaust lobe doesn't open? When the exhaust lobe doesn't open, you end up getting exhaust gases coming out of the intake. It ends up ruining what's called your air fuel ratio, and you're going to end up getting a lot of misfires and causing a lot of problems. Quake it of me. I see a lot of videos of shops that consistently talk about head gasket failures. Why is it so? Um, well, I don't want to get too far into like engines and head gaskets, but a lot of people run into head gasket failures, high miles. Some engines are designed like very poorly, and a head gasket failure is just something that happens with certain engines. Um, Kia. um, so that happens a lot, and just lack of maintenance. People don't maintain their vehicles well. They overheat their engines, and you blow head gaskets. Um, let's see. Direct injection. I don't have a diagram of direct injection in this lecture. Fuel mixes with the air. Yes. Let's see. Tell me more about diesel engines that have spark plugs. So there are some diesel engines that have spark plugs, and basically what that does is it just creates way more combustion. And like there are like U.S. military tanks that are powered by it. There's some like I'm also quite certain mining equipment is powered by these things. Cummins makes opposed piston spark plug diesel engines that make like 2,500 horsepower. It's pretty cool. Um, why would there be coolant in the valve cover but not mixed with the oil? Why would there be coolant in the valve cover but not? I don't understand. Coolant in the valve cover but not mixed with oil. I've never heard if you got coolant in your valve cover, it's getting mixed in because the valve cover just covers the valve train, right? And if you got coolant in there, it's mixing up. Um, let's see. So thoughts on mega? Well, listen, this is a great Dan, no. So diesel spark plugs aren't called glow plugs. Glow plugs just kind of heat up the air in the combustion chamber um, to start in really cold weather. They will actually use like spark plugs, like special spark plugs in only like these very special, not mass-produced diesel engines they make for only specific applications. It's very cool. Alex, a valve train is anything. So these are the valves, right? These are the valves. So the camshafts, right? There are some engines that have camshaft and rockers, like actual like rockers, or a single camshaft with push rods and rockers and stuff. So anything involved with opening and closing the intake and exhaust valves is called a valve train. That's what that is. Um, those are on the Tiger Shock. Okay, so maybe that's probably what they're called. They're probably called Tiger Shock engines. I don't know what those engines are called, but thank you for letting me know there. Let's see, what else do we have here? Uh, Alex, so I know diesels don't use spark plugs, but there are diesel um, diesel engines with spark plugs that they've made that for military use. They do exist. They're not for like normal civilian use. They do exist. It's very cool. My car drives great, but when I put it in drive, so I'll get to those questions later. Alrighty, so let's continue with the lecture here. Computer systems. Here's the deal. Uh, okay, so Dr. Strange will ask this is a very good question here. So is back pressure a myth, or is it just the shape of the exhaust that creates a vacuum? Back pressure is not a myth. Back pressure does exist. The myth is that back pressure is good for an engine. That's the myth. That's very wrong. You don't want any back pressure. You want a vacuum. You want all of those exhaust gases getting pulled out as quickly as possible. But back pressure will exist through limitations and barriers of an exhaust system, all the way from the exhaust manifold to whatever exhaust tip there is. The design of the exhaust manifold can create back pressure. Catalytic converters, mufflers, resonators, odd shapes, can increase or decrease back pressure. Um, Okay, so let's talk about computer systems. This is like the boogeyman. Okay, computer systems are the boogeyman of the automotive industry, and it's like, computers are trash and everything is this, and nothing is reliable, and blah 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 blah. And listen, to an extent, I think that's true, right? To an extent, there's a lot of things that are controlled by like modules and very sensitive computer systems that don't really need to be. And I completely agree with that. However, computer systems have dramatically increased the reliability of modern vehicles. They've dramatically increased the amount of horsepower, torque, and fuel efficiency we can get out of many different kinds of engines, and they were definitely a step in the right direction, at least in the beginning. And now it's kind of like gone out of control. That's my personal opinion. But computer systems basically there are multiple onboard modules that monitor and control vehicle functions. Okay, so think of a lot of vehicle functions. That's what computer systems do. They use sensors, actuators, and a bunch of other tools for real-time adjustment, diagnostics via the OBD2 connector and the other scan tools. So computer systems basically use a bunch of sensors. Um, and what's a sensor? A sensor. Let me zoom in here. So sensors are input devices that can produce or modify electrical signals with a change in a condition such as motion, temperature, pressure, speed, location. There's a lot of different. I'll give you some examples right now. The sensors are the eyes, ears, nose of the computer. So we have different kinds of sensors. Uh, uh, one of so a very popular feature on a lot of cars are automatic windshield wipers. Okay, an automatic windshield wiper system uses a wetness sensor. So there's a sensor that's on like right underneath your windshield, or depending on where it is in different vehicles, but it's somewhere there where once that sensor gets wet, it turns on your windshield wipers. It activates that circuit without you having to flip the switch, right? You have another sensor. You have like let's talk about like a automatic headlights, right? So you can put your headlights in. in automatic so that they can automatically turn on and off. And there is a sun sensor. It's called typically it's on the dashboard in a vehicle. And when that sun sensor um, uh, the sun sensor will take light and turn that into a voltage, right? And once the light dims, it'll increase or decrease the voltage depending on how that system is worked out. But let's say it'll decrease the voltage to a point where once the voltage is low enough, it'll trigger and like it'll trigger a switch and automatically turn on your headlights, right? For example, just kind of throwing things out there. What do the sensors connect to besides the battery and the ECU? Just curious things. I'm going to get right into that. It's a great question. So that's what sensors do. Then you have what's called an electronic control module, an ECM, an ECU, a computer, whatever you want to call it. That's the electronic control module. And it's the computer that uses signals from input devices to control various output devices. Okay? The control module is the brain of the computer. So you have inputs and you have outputs. You have a sensor and then you have an actuator. The sensor reads data, puts that data through through a computer, whether it's the ECM or some other kind of module, puts that data, and then that through the module. The module follows a logic process, and then it produces an output. And the output we could call it an actuator. Okay. Yes, I am recording, and I will post this up on TikTok, and I will post this up on my YouTube channel, which is also Official Best Mechanic. Um, so you have and this is how like every logic process works. In the most basic form, in the simplest form, you have an input, a logic process in a module, and an output. So your input could be your input could be uh, the water that hits that sensor, that wetness sensor, and then the output is the actuator of the windshield wipers working. Okay, for example, um, an actuator, a solenoid, a motor, absolutely, it's many different things. Um, so that's kind of how they all work. Um, and so that's really the basic thing, right? That's how you build. That's the foundation of all automotive computers and circuits, inputs and outputs, inputs and outputs. What gets overwhelming is when you realize that there are hundreds of inputs and outputs um, being processed like every second, sometimes thousands or tens of thousands of inputs and outputs being processed every second, which is insane, right? But as technicians, don't get overwhelmed because typically speaking, only like when a vehicle comes into your bay or you're trying to fix something, you're not typically you're not dealing with more than one system failure at a time. Typically, so it's not something that um, is very difficult, to be totally honest. Sometimes it'll get pretty complex, especially when you have like these older vehicles and manufacturers are still trying to figure out like better ways to like slap together their harnesses and their hardware and the electronic systems. But it's fun. It's look, there's instructions written out everywhere, and it's not magic or voodoo, right? It's just science and manufacturing, right? That's all it is. How can I find a broken wire in a coil pack harness? You got to just broken wire, test resistance of the harness, and if you have no resistance, then you could. If there's like no resistance or like infinite resistance, then chances are you have an open, right? My coworker and I are arguing about this question. I told him technically fuel cools yeah, fuel will cool an engine. Um, but then you have like different types of fuel that will cool it more. But like cooling something is relative. It's not like cool to the touch, right? Um, so the most complex issue I've ever had was the issue with the BMW 550i ignition coil shorted, killed the DME. Interesting, and damaged CAN bus wire in main harness. Wow, that's crazy. That's nuts. Um, let's see. Can a three-dimensional frequency table be used to display more complex data sets? As a tech, I've never had to really get that crazy with it, right? Um, I'm more using oscilloscopes. That's kind of as deep as you get with it as a technician is like using oscilloscopes. Um, so that's cool. It's much easier to get into learning how to fix cars. Okay, cool. I love the conversations you guys are having. Holy moly, guys, we're at 28,000 likes. That's so awesome. Let's try to get to 30,000 likes. So let's continue. So here is a nice example of what I was just talking about. So here we go. We have a gear shift sensor, a vehicle speed sensor, we have our computer module, and then we have our output, which is a door lock solenoid. A lot of vehicles have this automatic locking. So if your doors are unlocked and you start driving without locking your doors, typically when you hit like 20 miles an hour, you'll hear it. You'll hear all the doors lock at the same time, like simultaneously. And this is a um, very simple schematic of that entire system. You have a vehicle speed sensor. This is going to be like a tone ring or something, right? And this is probably a Hall effect sensor. So you have and then you have a gear shift sensor. And then you have a module. The module takes these two inputs, right? The first input is the gear shift, so it knows that you're in drive. So the module knows that you're in drive, and the module knows that, okay, I have speed. So it knows your speed, and it knows you're in drive, which, and if you're in drive, that means you're not in park. Okay? And then this goes through a logic process in this module. The module has power and ground, just like every circuit. And then um, at a certain speed, this module is going to tell this door lock solenoid to lock the doors. And that's how, bam, here we go. That is how automotive modules work, right? That there's an automotive computer system. That's an automotive circuit. We have inputs. In this case, we have two inputs, a module, and one output, right? And keep in mind, these inputs can be used for many other different types of outputs, but we're just talking about one system, and we're talking about this automatic door lock system. Pretty simple. It doesn't have to be overwhelming. Um, so it doesn't have to be overwhelming, and it most of the time really isn't that overwhelming. Sometimes it could be complex, and I will say that like in a professional setting, and by professional setting I mean in a repair shop, whether you're at an independent shop or a dealership or whatever it is, it can get really difficult depending on how much pressure you're under and like if what you're dealing with is like a newer system, right? So like if a brand new vehicle comes in or a vehicle you never worked on comes in and it's got an issue with this system and you don't know how that system is engineered, you don't know what the wiring diagram looks like, you don't know what kind of fuses there are, you don't know the routing of the harnesses, you don't know the connectors or the pins. But if you've had the same issue on the same type of vehicle over and over and over again, it gets a lot easier to figure out and diagnose. Um, so let's see here. Thank you, Nick James, for the follow. Thank you, Money Monster 37 for the follow. I'm looking for some more questions here. Looks like we don't have too many questions or any questions about modules here. Great conversations you guys are having. Um, okay, so let's continue. And now here's a more complex. Okay, so here's a more complex kind of overview of how um, computer systems are used for the combustion cycle, how it controls an engine. So let's get into it. This is really really fun. So we're gonna start with the fuel. So you know what? How can we do this? Let's start from here. Let's start from the meat, right? And we'll work our way back. So we need four things, right? We need air, we need fuel, we need compression, and we need spark. Those are the four things that we need. So we're gonna go back. So this is our fuel injector. This is direct injection, by the way. This is our fuel injector. This is our spark plug. And then this is our crankshaft. This is our piston. So let's figure out how all these things are related to each other. So first things first, we have our fuel tank, and inside the fuel tank we have a fuel pump, and that pumps the fuel out. into the fuel injector. Cool. Looking okay, just sorry, just checking the comments, making sure everyone's on the same page. So it goes into the fuel injector. At the same time, here's our engine control computer. We know so at the same time the computer knows that the ignition is on. Here's our ignition control module, and our ignition control module is trying to figure out when to fire that spark plug. That's what that's trying to do. It's trying to figure out when do I send power to the spark plug so the spark plug sparks at the right time. And the way it's learning that, so notice this ignition control module is hooked up to a temperature sensor. There's a coolant temperature sensor. It's hooked up to a crankshaft position sensor. It's hooked up to a crankshaft position sensor. It's hooked up to ignition, and it's hooked up to the battery. So this ignition control is letting us know that the ignition is on, the car is on. It's letting us know that what the crankshaft position is, because that is going to tell us where the piston is, and it's also letting us know where the temperature sensor is, letting us know temperature, just so that in case the temperature is too hot, it'll go into like a limp mode or it'll do some kind of strategy. It's also connected to the engine control computer through the same harness over here. The engine control computer. So notice, so these are called what? These are our inputs. It goes through our module, and it's going through another module because these two modules talk to each other. And then here we are. Here are our outputs. Our outputs are fuel and spark. So we, uh, uh, based on the inputs of crankshaft position, of temperature, and ignition, we get the outputs of fuel and spark. And on these modern engines, you also get the output of how much fuel as well. So you have variable valve timing. You've got different like different types of fuel injection, multi-port, direct injection on a lot of vehicles now, turbocharging a lot of vehicles now. So there's a lot more complex, but that's that's basically it. This looks a little bit more complicated, but it's so easy. And then you just have a fuse box, and the fuse box is there just in case there's any kind of um, extreme load. Instead of burning up the entire car and burning up the harness, a fuse just blows and it saves the vehicle, and then you got to figure out why that fuse blew. How do modern engine controls unit use dynamically balanced uh, control units? How do modern engine control units dynamically balance air fuel ratio? All of that has to do with what's called the air fuel ratio sensors or your bank 1 O2 sensors, and how all of that stuff communicates, and how they basically read how efficient the combustion is, and how all of that, there's so many inputs. So basically, all of the inputs go into those air fuel ratio sensors, and it's just trying to keep the air fuel ratio at like 14.7 to 1. And then it sends everything to the ECM. So it takes all those inputs and then it outputs um, fuel and spark and throttle body control. And if it's turbocharged, wastegate actuation and boost pressure and all this other stuff, right? So it does a lot. Um, it does a lot in that regard. In that regard, I'm a mechanic. I'm not an engineer. Um, so that is that's kind of how all that works. I know it may have been a little. I don't know if I explained that very well. I hope I explained that very well. But if I did not explain that well, please let me know. If you have any questions or comments, I'll give you guys a quick second. Thank you so much for the likes. 31,000 likes, incredible. Um, yes, I do know how to do alignments. So let's see. No questions about this. I can move on. Okay, thank you very much. Thank you, simply Signori. Thank you very much. Next, thank you for the follow. So here we go. Next up, ASC exams. All right, automotive careers and ASC certifications. There's a high demand for skilled technicians. Okay, certification validates expertise and professionalism, and continuous training helps keep the skills current. Here is the deal. Okay, here's the deal. A lot of people have many opinions on the validity of ASC exams. The reality of the situation is if you want to keep yourself competitive and you want to increase your level of pay and you want to be able to easily progress in your career, whether you're at a manufacturer or you're at an independent shop or you're working for a government agency or whatever it is, you have to get your ASC exams and you have to become an ASC master technician. You have to do it. If you don't do it, you're limiting yourself. Now, I'm not saying that if you don't do it, you will never be successful. I'm not saying that. What I am saying is it's a door to opportunity that you really want to be able to open. Um, Something very important that I want to point out: high demand for skilled technicians. Okay, skilled means my definition. Okay, my definition of an entry level skilled technician is someone who can diagnose problems correctly the first time. So if you are good at diagnosing things, you're skilled. But if someone else diagnosed it and you're just throwing parts at it, you could be a skilled mechanic, right? But the difference in a mechanic and a technician is the mechanic just does nuts and bolts and just kind of puts things together and takes them apart like Legos. And technicians use technology, logic processes, and data to figure out exactly what's wrong. Okay, and then they can also fix it. So that's the big thing there. Um, how hard would it be to change a gas car to EV? It's extremely difficult. It's an extremely difficult thing, but I've seen some people do it. It's pretty cool. Icarus forever. Have to. False. That's it. So no, I didn't say have to. I said you can succeed without them, but if you should always want that door opened, right? You always want to be able to open that door. So I think I have. So look, I have a manufacturer master technician certification, and I have my ASC master technician certifications, and it's helped me tremendously. It's helped me tremendously, not just in um, being able to get paid, but also just in my knowledge base and the connections I've been able to make in my career. Is getting certified hard or is getting certified difficult? Sort of. What it really comes down to, so the ASC exams don't test how good of a mechanic you are. The ASC exams are comprehension exams, right? It's reading and understanding how they're asking you a question and what type of answers that they're looking for. So if you have a hard time reading, right, you're gonna have a hard time with the ASC exams. Are they impossible? No. Are they difficult? Not really. Um, the hardest or the most difficult part about the ASC exams is the time limit. That's my personal thing. With me, the hardest part I had was managing my time in things because I will just hyper focus on a question, but you got to remember every question is worth the exact same amount of points. So if there's a question that I'm focusing on and I'm spending 5 6 minutes figuring out this question, I could have probably answered 3 or 4 more questions, in that process. So we got a lot of ASC questions here. Um, Let me go ahead and answer them. I have two ASC certifications in the entry level. Are they the same, basically, questions wise? Yeah, basically. Yeah, absolutely. Because there's something called ASC style questions, and it's essentially the same style. ASC is only a pedestal for the shop to stand on. I know numerous excellent techs that can't pass it. Yeah, absolutely. Listen, I know really great mechanics that are functionally illiterate. I've met so many of them in my career. And because they're functionally illiterate, they will never pass the ASC exams. I know a bunch of great mechanics where English is their second language. And because the ASC exam's only available in English, they're never really going to pass them, right? But um, again, it doesn't determine whether or not you're a great mechanic. All it is, look, somebody invented this game, right? I'm telling you guys, I'm advising you got to play the game, right? I played the game, and you sit there and you got to get these certs and do these things and be like, hey, I have this, give me money. Okay, and they're gonna be like, okay, well, we'll give you money, but like, can you actually do the work? And that's where you do business, right? That's where you're asking for money, and they're asking for skill, right? Skills, and then you have to demonstrate skills, and if you can demonstrate skills, you get money. Okay, Um, let's see here. ASC is Automotive Service Excellence. That's like the name of the organization. ASC exams are easy if you pay attention. I agree. Is this like the mechanics? Yeah, basically, it's like the mechanics ACT or SAT, right? For those, yeah, that's a basically that's a good way to put it. Heard functional stupidity and immediately joined. I have four entry level AC certifications. How are they different from the normal ones? Um, when you say entry level AC certifications, are you talking about like high school level? Because I never took the high school level stuff. I know that like a lot of high school like tech schools they have ASC stuff, um, but I'm not sure. It's probably just more questions. Is trade school worth going to? I think so. I went to trade school. I went through the Ford Asset Program. And I ended up teaching the Ford Asset Program for 3 years, and now I'm not doing that anymore, not teaching anymore. But I think trade school is worth going to. I do not think UTI, Lincoln Tech, and Waco and those. I don't think those are worth it only because of the price. The price is the only reason why I don't think those places are worth it. I think the level of education is very good. Um, but spending 40, 50, $60,000 in 1 year to get a job that's going to start paying you maybe 20 is ridiculous. Um, so if you, I would say, like go to a community college, get you like your 2 year community college degree, or if there are in some state, I would say in many states, but probably mostly in the Midwest, but in many states there's adult learning classes at community college, so like night classes for this as well, so you could work in the day and take classes at night. Um, um, Wyotech again, Wyotech, unless you get like a full scholarship to these places, I just don't think it's worth that much money. Um, it's just too much. It's too much for. Listen, if I'm sitting there and I'm going to pay $80,000 to become a mechanic, and I'm going out and my first job is going to be paying me $85,000 a year plus 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 plus. You know what? Maybe it's something I want to do. But I've seen so many guys like in my shops that I've worked at, um, people that I've met, during my time in education, where it's like, they're 60, 70, $80,000 in debt, just tuition wise, and then they get into Snap-on and they get a Snap-on box and they get Snap-on tools and they owe the tool truck $14,000, and then they're sitting here and they're making $15 an hour, and I'm like, what are you guys doing? It doesn't make any sense to me. I think it's predatory, to be totally honest. But again, that's my opinion. Um, and that's basically it. What are your thoughts and explanation of captive bolts? I've never heard of captive bolts before. Let me know what you're talking. I probably know them as something else, but educate me, my guy. All right, and I believe when you leave Biotech, you don't even have it. Yeah. So 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 I used to also recruit, right, for when I was teaching the asset program, and I would tell them like, listen, you get a whole associates in applied science, right? You get an AAS degree plus all the four certifications. And that was like one of my main selling points against UTI and Lincoln Tech. So then UTI came out with something called a AOS, I think, degree, which is like an Associate of Occupational Sciences, which is some BS. Let's be completely honest, right? It's some kind of BS. Um, just so that they could tell people, hey, look, you have a degree, you have an associate's degree. It's garbage. Because an Associates of Applied Sciences, you could take that and apply that towards a bachelor's degree. But an AOS, you could take that and throw it in the garbage. There's nothing really much you could do with that. Um, what tip can you give to a 17-year-old? Stay sober, stay out of trouble, work hard, don't get into debt, take care of your parents. That's the tips I can give 17-year-old. Can you make good money when passing your ASC test? You can. Just got your ASC. Congratulations, Jaden. You can. Typically, repair shops, whether they're independent or dealerships, will give you like $1 or $2 per ASC exam that you pass, and then when you become an ASC master, you also get a pay bump. So that's pretty cool. Hey, my brother just got flown out to Savannah and won an ASC. That's amazing. An ASC award. That's amazing. So okay, let's see. I think I have some more. And that's basically it. So, quick summary. Automobile is a system of systems. Okay. They're very complex systems. Mastery of each foundation area leads to ASC success, and safety, ethics, and learning build longevity. I didn't really talk too much about safety and ethics. I wanted to get into that in the ASC stuff. Um, as mechanics, we are the professionals, and we are typically we know a lot more than our customers do. Okay, we are the professionals. There's a lot of mechanics out there that take advantage of customers. There's a lot of mechanics out there that lie to the service writers. They commit warranty fraud. Ethics is your best friend. Listen, you could sit there and scumbag your way through your career, but you're gonna get got. You're gonna get got one way or another. Um, and if you want there are many things you need in order to have like a long successful career in this, but one of the things you definitely that will definitely keep you like safe and out of trouble and like always having a job is solid ethics. You got solid ethics, you don't commit warranty fraud, you don't fraud out a customer, you're not lying to your service writers or your service managers or whatever. You're following the rules, right? You're being honest. You're fixing things. You're keeping the customer safe. You're going to have a nice long career without anybody breathing down your back. Is 2,200 a week bad for a 20-year-old mechanic with no certificate? No, 2,200 a week is incredible. You're killing it if that's what you're doing, my guy.